So I want to welcome today to today's class on determinants. We shall be looking at 3 by 3 determinants and 2 by 2 determinants. So I'll start with the 2 by 2 determinant. How do we calculate the determinant of a 2 by 2 matrix? Basically, it is easy. So given matrix A is equals to A, B, C, and D, the determinant, which is represented by this, the determinant, when you put that magnitude, will be given by AD minus BC. Will be given by that. So you multiply the leading diagonal. We discussed about that. Then you subtract the minor like that, like that. Then you subtract the minor diagonal. I'll be able to do an example. So given A is equals to 4, 3 and 2 and 2, 1. So the magnitude of this one A will be given by 4 times 1 minus 2 times 3. If you do this one correctly, I'm getting it as negative 2. That will be the determinant of the 2 by 2 matrix. So if I want to do, I can be able to do another one, number 2. Let's say B is equals to 1, negative 2, 3, 5. The magnitude which is by the magnitude of that, the determinant will be given by 1 times negative 2 minus 5 times 3, which will be able to be the same as negative 17. So we are calculating the determinant of a 2 by 2 matrix. I'm able to do the final one. 4, 6, negative 1, 2. We can call this one matrix C. The determinant of that matrix C will be given by 4 times 2, and then minus negative 1 times 6, the same as 4, minus 6, the same as 10. So a negative times a negative will be able to give us what? Positive. So that's how we calculate the determinant of a 2 by 2 matrix. So I'll go now to a 3 by 3 matrix. 3 by 3. So given this matrix, A, B, C, D, E, F, G, H, and I. And call this one matrix A. So to get the determinant of this matrix, just like what we are doing on vectors, we shall block. So we shall reduce this one to a 2 by 2 determinants, and then we have it. So we shall be able to take the first one. So the signs are very important again. The sign again will be able to take place here. So this one is on the A, we shall have positive, negative, and then positive. Just need those three to be able to evaluate 3 signs. Positive, we always start with positive, then we go to negative, and then positive. So I'll take the A, that is positive A. The determinant of this one A will be given, so positive A. Then I'm saying I'm reducing this one to 2 by 2, so I'll be able to block the row and the column. So the one that are remaining one, remaining one is EF and HI. Then minus B because of the sign. Again, I'll block the middle column and the first row, so I'll end up with D, F, and then GI, and then plus C. Then when I block the final row, the final column and the first row, I'll end up with DE, GH. And this one is just 2 by 2, whereby I'll be multiplying the leading. This is what I mean. I'll be multiplying the leading I'm multiplying on the leading, the one I'm showing with the arrow, the leading minus the minor. So the one that is an arrow, that is the leading diagonal. What we had done by 2 by 2 matrix, that's what I'll be doing. The leading minus the minor. Then I multiply with a multiple of A for the first one, this one, and a multiple of A. Then the other one, the leading minus the minor. Then I'll multiply with the factor of negative B, and then finally with the factor of what? C for the final one. So that's how we do it, basically for a 3 by 3 matrix. So let me do an example, demonstrate the determinants. So number one, let's get the determinant of this one. Determinant of that matrix there. So I'll start with the signs first of all. Start with the sign. So this one is positive. One is positive, negative, and positive. The sign is very important. If you forget about the sign, you will not be able to do it. So we have the signs positive, negative, and positive. So the first one, I'll call this one matrix, let's say A. The determinant of this one, A, will be given so that the first sign is positive, 1. And then when I block, I remain with 3, negative 2, then 1, 5. The other sign is negative, so I'll have negative 2. Then when I block, I'll end up with 4, negative 2, negative 2, and 5. The other sign is what? The other sign is positive, but I have here negative 1. So when I block, I will end up with 4, 3, and then negative 2, 1. So the blocking, you just block the row and the column, basically on the first elements. So this one, when I simplify this one, I'll end up with the 1. So you have said the leading minus the minor. So I'll have 3 times 5 minus 1 times negative 2 at the first bracket, then minus 2. So I'll have 4 times 5 minus negative 2 times negative 2. Then the final one I'll have, it will be negative 1, negative 1. Then I multiply 4 times 1, 4 times 1, and then 3 times negative 2. 4 times 1 minus, I think it was 3 times negative 2, or negative 2 times 3, doesn't matter. So it is a matter of time now. I open up the bracket, so that is 15. 15 plus 2, you get 17, so I'll get 117. And then minus 2, that is 20. 20 minus 2, you get 18. And then minus 1. So I'm evaluating whatever that is in the bracket, that is 4 plus 6, you get 10. When I open up the bracket, let's see what I'm getting now. I'm getting 17 minus 36 minus 10. Then you just apply it to the calculator. Always good to have a calculator. That is 17 minus 36 minus 10. It's coming to negative 29. So the determinant is a negative, is still okay. So you're getting it as negative 29. Determinant of this matrix, of a 3 by 3 matrix. So let's go to the determinant, another example, determinant of a 3 by 3 matrix. So given this matrix, our A is equals to 4, negative 1, 2, 1, 0, 5, -6, then 1, we have another one, and then -2. We try the determinant of that matrix. So basically the determinant is given by this one, the magnitude. That one signifies the determinant. So what we shall do, we shall do the signs first of all for the first three. We do the signs. Don't forget about the signs, they are very important. So this one is positive, negative, and positive. We shall come back to cofactors, and we shall be using the same. So we are just concerned with the first three, with the first row only for now for the determinant. So we shall have +4. Then we block as what we had done on vectors. We block. So when I block that one, the row and the column, I'll end up with the determinant of supposed to be a straight line. That is 5, -6, 1, and -2. And then this other one, the sign is negative, and then I have -1. So I'll have what here? So when I block the row and column, I'll end up with 1, -6, 0, and -2. The other sign is positive, so +2. So when I block, I'll end up with 1, 5, 0, 1. So it's a matter of now opening up. We open up. So basically for 3 by 3, we are reducing to a 2 by 2, a determinant to make our work easier. So that is a 4. 5 times -2. In the next example, I'll jump this step of writing the 5 because we can easily multiply. I'll jump that step. So 5 times -2, and then 1 times -6. And then the other sign was what? It was negative, sorry. The sign was negative, so I'll get +1. To be able to check, I had -1, but the sign was negative. So I'll end up with +1. End up with +1. And then here I'll have 1 times -2 minus 0 times -6. The other one is +2. I'll end up 1 times 1 minus 0 times 5. When you open up the bracket, the first one is -10 minus -6. Yes. So you get 4. So that is what? -10 minus -6, get -4. So a calc will be able to do this one for you. You don't have to worry. And then 1, and then that is -2 minus 0, still -2, and then +2. Then I have 1 minus 0 is still 1. So when I do this one, that is -16 minus 2 plus 2. End up with what? 16. I will end up with 16. So Stephen, kindly mute. Yes, I'll end up with 16 for this one. So that is the determinant of what? No, have I done it correctly? No, -16 supposed to be -16 because the first one was negative. So I'll do another one for the determinant of a 3 by 3 matrix. So this is what we have. Another example. Let's say B is given by this one. We try to determine the determinant of that matrix. The determinant of this one, again, we shall start with the signs first of all, with the first row. You always begin with positive, negative, and then positive. So this element here, this element will take positive and will take negative, and this one will take positive. So the signs are very important, very, very important. But the element that is affected basically is, can be able to see, is the element on the first row, second sorry, first row, second column. The other ones always remain positive. So the one that is affected is basically the negative 6. So the B, that is the determinant, is given by that. So I'll take the 5, positive 5, the sign, and then I'm reducing to a 2 by 2. I block the row and the column. I'll end up with 0, 2, negative 1, 4. And then the other sign is negative. I still have a negative 6 there. It's always good to put brackets so at least you don't confuse. I block the row and the column. I'll end up with 1, 2, 3, 4. The other one is positive, but I have negative 7. I put brackets. When you have two signs, always put brackets. So when you block, I'll end up with 1, 0, and then 3, negative 1. So this one I want to I said I'll jump a particular step by just multiplying the leading minus the minor diagonal. So this one is the leading, the one that I'm putting in blue, that is the leading. I multiply the leading, and then I'll subtract the other one. So the one that is in blue is the leading diagonal, and then I subtract the other one. So this is what I'll be able to end up with. 5. That is 0. When you put 0 minus 2, you end up with just 2. The other one will be positive 6. The other one is 4 minus 6. You'll end up with negative 2. And then negative 7. That is negative 1 minus 0. You'll end up with still negative 1. Then that is 10 minus 12 plus 7. With the answer will end up to what? 5. The answer will end up to 5. So you multiply the leading diagonal minus the minor diagonal, and I've been able to show you, even when you are doing the 2 by 2 matrix. Final example. Let's say we are given this matrix: negative 2, 3, 7, negative 6, 1, 0, 8, we have negative 8, then negative 1, then let's say 4. Determinant of that one. So again, I'll start with the signs. Very important. So this one is positive, negative, and positive. Then from there, it's a matter of just reducing to a 2 by 2 by blocking. So the determinant of C, that one will be given by, the first one is positive, so I'll have negative 2 outside. Then I block. When I block, I'll end up with 1, 0, negative 1, 4. The other sign is negative, so I'll just have negative 3. When I block, I'll end up with negative 6, 0, negative 8, and 4. And the final one is positive 7. When I block, negative 6, 1, negative 8, negative 1. So here a calc comes in handy for you to be able to determine. So we shall be multiplying the leading diagonals. I'll be able to mark them in what? In green. So that one times that one, that one times that one, and then we subtract the other one. So that is the leading diagonal we shall be doing. So this one will get negative 2. So that is 4 minus 0. You still end up with a 4. Then negative 3. Using a calc, that is negative 24 minus 0. You still get negative 24. And then plus 7. The other one is negative 6 times negative 1. That is 6. 6 minus 8. We are getting it as 14. So when I'll put this one in a calculator, everything, I just multiply. So this one I'll be able to get it as negative 8. Negative 3 times 24. Negative 3 times 24. I'm getting positive 72. And then 7 times 14, I'm getting it as 98. When I add all these, 98. Yes. Yes, Bran. Okay.
I was connected to the echo. No, there is no issue.
Okay, sir. 162. I'm getting as 162. So you can be able to get a big number on the determinant, but it is still okay. I don't think we'll have any problem in that. So that's how you calculate the determinant of a 3 by 3 matrix. Let me pause on the record. Let me show you, and you can be able to go and try and see. So for example, if we have a 4 by 4 matrix, your main work is just to reduce it to a 3 by 3, then a 3 by 3, reduce it to a 4 by 4. For example, a 4 by 4 matrix A is given by, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Something like that. That is a 4 by 4 matrix. So if you do the determinant, you still come again to the signs. The signs are the same. That is positive, negative, positive, negative. So that's what we'll be able to have. Then now, what you need to do now is to reduce now by blocking again. So the first element, I'll have positive 1. This one is just for your sake, positive 1. Then I'll end up with what? When I block, I'll end up with 6, 7, 8, 10, 11, 12, 10, 11, 12, and then 14, 15, and 16. I'm just doing for the first element. I'm just showing you for the first element. So you can be able to see what you have here. You have positive 1, then you've been able to reduce your matrix to a 3 by 3. Now again is your task again to reduce this 3 by 3 into what? Into 2 by 2. So again you'll come again with a sign. Then will be positive, negative, and positive. So again you reduce that one to a what? You reduce that one to a what? To a 2 by 2 matrix. So the positive 1 will be here outside, no problem. This one again now you come and reduce now. So what will you end up with here? You'll end up with 6. The first one is positive 6. And then 11, 12, 15, and 16. And then negative 7, 10, 10 what? 10, 12, and then 14 and 16, and then positive 8, positive 8, 10, 11, 14, and 15. So you can be able to see it is doable now. Whatever the outcome you'll be able to get for a 3 by 3 matrix, you shall be able to multiply with what? Positive what? The positive 1 that is outside, the one that I'm circling. You just be able to multiply with the positive 1. So you start with a 4 by 4, you go to a 3 by 3, and then you reduce to a determinant of a 2 by 2 matrix. Because these determinants here, it is possible to evaluate these determinants. They are easy to evaluate. So that is just for your curiosity. You can be able to do one and you tell me what you are getting. Yes.